Good morning, my YouTube viewers. It is Crystal here. And this particular video I'm making is a Kaggle competition that they have their monthly competition. And this particular competition is you're going to predict on the probabilities of a banking data set. And to be perfectly honest, the data doesn't give you a lot of information about it, so I'm not sure exactly what I'm predicting on. I don't know if I'm predicting on whether they're going to default on a loan or whether they're going to get a loan, because I looked at the documentation for the competition and it doesn't really say. It just gives you the data set. And so I've been working on this since yesterday. And if you've been watching my other videos, you'll know I've been making videos on statistics. And now I'm trying to put the videos that I have on statistics on Medium publications. And I'm only allowed to upload 3 blog posts a day. So it's taking me a while to actually upload the blog posts. And so as a result, I'm working on this Kaggle competition in tandem with uploading my blog posts, which is not an easy task because I made the blog post in Word. I copied and pasted it from Word to Medium, but the pictures didn't copy over, so I have to copy and paste the pictures again after I've copied and pasted the article. So now you know what's been happening with me this past month. And so now what we're going to do is we're going to do a code review of the code that I wrote for this Kaggle competition for August. And it's Play 5.8 HistGradientBoostingClassifier with sklearn. And then it took me a while to do it because I tried extra trees first. And I may very well go ahead and make a video on the extra trees one, because the reason why is because on the extra trees one, it gives you feature importances, but on HistGradientBoostingClassifier, I don't think that you get the feature importances. So I may actually make 2 videos on this one competition so I can cover all of the information. And on the extra trees classifier one that I did, I actually got a bronze medal. And I'll tell you more about that as we get to it. So I don't witter on. I'm going to go ahead and start with the code review, because that's what you want to see is the code review. So I made a 96% on this particular competition question. I didn't win, but it was really high. And then the problem statement is use banking data to make probability predictions. And as I said, there was not a lot written in the documentation, so I don't know what we're predicting on. It doesn't say what we're predicting on. It just says Y, because Y is your target. So the first thing we're going to do after we make our problem statement is we're going to import our libraries. So we're going to import NumPy as NP, which is a numeric library, and it also creates NumPy arrays. And then we're going to import pandas as PD, which is a data processing library, but it also makes data frames and series. We're going to import OS, which goes into the operating system of the computer. From SciPy.stats, we're going to import KS_2sample. So this is a non-parametric test, and what we're going to do is we're going to test to see if any of the features in the train and the test data set are not from the same distribution. And if they're not from the same distribution, then we're going to remove those features. And the reason why is because that will just cause problems. We're going to import matplotlib.pyplot as PLT. which is a visualization library, and we're going to import Seaborn as SNS, which is also a visualization library. We're going to retrieve our files using OS library, and then the files that we're going to retrieve are going to be sample, submission, train, and test, and they are CSV files. So now we're going to read the files. So we're going to use pandas to actually read the files, and then the files, we're going to call those train, test, and submission. So we're going to set it up so we can view all of the columns. That's pd.setOption brackets display.maxColumns, none. So what that does is that sets up the file, the Jupyter Notebook, so you can see all of the columns. If you don't set it up this way, you won't be able to see all of the columns. So now we've got our train data frame. It has ID, age, job, meritable, education, default, I guess that's default on a loan, balance, housing, loan, contact, day, month, duration, campaign, P days, previous, P outcome, and Y. So I don't know what P days and P outcome is for, and Y is your target, but I'm not sure exactly what it's predicting on, and the documentation didn't give a lot of information about what it was predicting on. We've got our info, so you can find out what the information about each column. So you've got integers, objects, and floats, or really just integers and objects. I'm not sure if there's a float in there. I don't see any floats, so it's just integers and objects. So at some point, the objects are going to have to be converted to integers. So now what we're going to do is we're going to find out all of the unique categories in each column that is of D-type object. So you can see job has categories of technician, blue collar, student, admin, management, entrepreneur, self-employed, unknown, services, retired, housemaid, unemployed. And then so each feature that is a D-type object has a value, a categorical value. And so we look all that up because that's going to be important when we analyze it. And then so now we check to see if we've got any null values, and no, we do not have any null values. So we look at the test set. The test set is the same as the train set, except the test set does not have a column that says Y, because the column that says Y is your target, and that's what we're going to be making predictions on. So we check for null values in the test set, and there's not any null values in the test set. And then we check for categorical values in any column that is of D-type object, because I wanted to see if any of the categorical values in the test set were different from the train set. And I didn't see any differences between the train and the test. And now we've got submission. So submission is your ID, and it's also your Y value. So you're going to be predicting on the probability of getting a 1. And since you're predicting on a probability, it's going to be a percentage between 0 and 1. So now what we're going to do, this is a non-parametric test, the Kolmar-Gorov-Smirnov test. And what you're doing is you're checking to see if the column, any of the columns in the data set are not from the same distribution. Because if they're not from the same distribution, then it's going to affect your reading, and we would just drop those columns. And the only column that was not from the same distribution was the ID column, but we would drop that column anyway. And the reason why we would drop that column anyway is because Pandas automatically indexes each row of data. So now what we're going to do is we're going to analyze the trained data set. So we're going to analyze the target, and you can see that you have a class imbalance between zeros and 1. You have a lot less 1s than you do zeros. Now we're going to analyze the age. This is a histogram of the age, and you can see it's skewed to the right, and you have a lot of outliers. So you've got people as old as 80 or older, but the main ages stop around 60, and then they start dwindling after 60. But that's the ages that we've got in this data, in the training set. So now what we're going to do is we're going to analyze the job, and you can see that the technician is more value counts than any other. So you've got the technician the highest, then the blue collar, then the student, and at the lowest you've got unemployed. And so what that's doing is that's telling you how many people of each occupation. Now we're going to analyze the marital status. So you can see 64.1% are married, 26% are divorced, and single, and 9.9% are divorced. So you can see most of the people in the data in the training set are married. Now we're going to check the education. The 53.6% were in secondary education, 30 or had completed secondary education. 30.3% had completed primary education. 13.3% completed tertiary education, and 2.8% were unknown. So most of the people completed secondary education. So now what we're going to do is we're going to analyze the default, and you have lots more people who did not default on a loan that you did, but still a portion of people did actually default. So now we're going to check housing, and you say that less people had housing than didn't. Now we're going to analyze loans. So a lot less people got a loan than did. So now we're going to analyze contact information. Most people, 64.9%, wanted to be contacted on their mobile phone. 4.2% wanted to be contacted on the telephone, and 30.9% was unknown. Now we're going to check analyze the day. So this is the day of the week that people were contacted or got a loan or something. And it looks like on the 20th of the month was the day that most people got their contact or got their loan or whatever. Now we're going to analyze the month. August was the highest level month when people, I'm assuming they got loans, and December was the least amount of loans or finances that they had. So now we're going to check the P outcome. I'm not sure what P outcome is, but 89.7% was P outcome. 2.0% was success. 2.4% was failure, 6% was other, and 89.7% was unknown. So now we're going to make a heat map of the numeric columns of the data frame. So you can see the numeric columns of the data frame, and you can see that the light green is the least correlation, and the dark green or the dark blue is the highest correlation. So you can see that these columns were not very highly correlated. So now what we're going to do is we're going to use sklearn's ordinal encoder to encode all of the columns that were a D-type object. So we're going to transform the train data frame, and then we're going to transform the test data frame. So then we go through and we check the information on the data frames, and you can see now that it's on integers, floats, and it just integers and floats. So all of the columns of data that were a D-type object were converted to floats. And then the same thing with the test data frame. So now we're going to define our dependent and our independent variables. Y equals train pop Y. So what that does is that just pops Y out of the data frame. And X is train and X test is test. So we're going to use sklearn's train test split to split the X and Y variables into training and validation data sets, which we did. We're going to define our model. Our model is HistGradientBoostingClassifier. Class weight is balanced. Max IDER is 1000. Random state is 42. We're going to fit X train, Y train. And the score is 89. So Y pred is model predict X val. And you can see that's prediction on the validation set. The accuracy is 88.8. So we're going to analyze Y pred. We're going to make a bar chart. And you can see that you have a lot more zeros than you have ones. So now we're going to predict on the test set. But since we're making probabilities, we're predicting on the probability. It's going to be pred equals model.predict proba X test. And then we're going to be predicting on the probability of getting a 1. So pred, and then we're going to look at all of the rows of data, but column number 1. And you know that in Python, the first number starts with 0. So it's really going to be the second column that you're looking at. So we're going to prepare the submission. So submission Y equals pred, and then column number 1. And that is the mistake that I made yesterday. Yesterday I just said pred and I didn't say pred column number 1. And so that gave me a really low reading, and I wasn't sure exactly what the problem was. And the problem was because I hadn't specified that it was all the rows in column number 1. And submission, we converted it to a CSV file, and then we converted it back to a data frame, and we read the data frame. And these are the probabilities that we had, and then this is what we submitted to Kaggle for submission. And then when we submitted it to Kaggle for submission, we got a 96.7%, which it wasn't the highest score, but it was a high score. So that concludes the code review on this particular model, this particular algorithm. But I think that because I figured out what the problem was and why I wasn't getting a high score, I think I'm going to go ahead and do a code review on the extra trees as well. And the reason why I'm going to do a code review on the extra trees is because the extra trees, we do feature importances, and I want to show you feature importances as well. So thank you so much for watching my video. If you like my video, please like and subscribe, and I will be making another video for you on the extra trees very soon.